Assalamu alaikum. Today my presentation about numerical. Myself Abdullah Arijo from 2K70 LCS 49. Final year student of CSSUL. Numerical analysis. Overview: fixed point method, Jacobi method, resolution method, shifting operation, system of equation, sequence method. Fixed point. Here you can see draw of fixed point finger. Number 1, the graphic of y is equal to x black small break and y is equal to cost x blue interest. Equation don't have to become very complicated before simple solution method. Give out consider for example the equation. X is equal cost x is quite clearly has at least one solution between 0 and 2. The graphics of y is equal x and y is equal cost intersect. Here is the finger spread toward the root for minus 1g small bracket 0 and zigzag toward the root for 0g bracket 1 small bracket 1. Finger 3 spread away from the root from g small bracket minus 1 and zigzag away from the root for g small bracket 1. But observe the following. Let's suppose we start with an initial statement of 0.75 as the solution of our equation. Now cost small bracket 0.75 small bracket is equal 0.731689. Cost small bracket 0.731689 small bracket is equal 0.744007. Cost small bracket 0.744047 small bracket is equal 0.735734. Cost small bracket 0.735734 small bracket is equal 0.341339. Cost small bracket 74139 small bracket is equal 0.737565. Cost small bracket 73765 small bracket 0.740108. Cost small bracket 74018 small bracket 0.738396. Cost small bracket 0.737565 small bracket is equal 0.738396. Cost 0.738396 is equal 0.739549. Cost small bracket 0.739549 small bracket 0.738772. Cost small bracket 0.738772 small bracket 0.739296. It is a clear that our solution is approximately 0.39. However, the approach known as the fixed point iteration doesn't always work. Jacobi method. The Jacobi method is method is of solving metric equation or metric that was zeros along its main diagonal both in and symmetry 9097 p 8097 small bracket. Each diagonal element is solved for and improvement value plugged in the process in the iterated until the coverage. The algorithm is stripped down version of Jacobi transformation method of metric diagramization. The Jacobi method easily derived by examining each of the equation in the linear system of equation is isolation. If the equation 1 solve for the value of while excuse the order in terms of remain fixed the gives. Number 2, which is the Jacobi method. In the method, the order in which the equation are examined in a arrangement since the Jacobi method treats them independently. The definition of Jacobi method can be expressed with matrix S3, where the matrix and represent the diagonal, strictly lower triangular and strictly upper triangular part of representatively. Resolution method follows flows in which shock wave and turbulence are present and interact dynamically occur in the wide range of application, including intertrail confusion, superwave acceleration, and scriptjective propulsion. Accurate simulation of such problems are challenging because of constraint requirement of numerical method used to simulate turbulence, which must minimize and numerical dissipation that would otherwise overwhelm the small squirrels and shock capturing chimneys, which introduce numerical dissipation to stabilize the solution. The objective of the present work in the evaluate the performance of several numerical methods capable of similarity holding turbulence and shock wave are compressed range of higher resolution method WENO, hydro wind central difference artificial difficulty data bed characteristics based filter and shocked fitting and suite of test casing. Taylor Green works to usher problem shocked vacancy entropy wave interpretation no problem compressor isotropic turbulence event to problem with shocks and turbulence and are considered. Shifting operators. In the difference table for nx, the first column corresponds to equidistant data values of fx. Middle bracket I is equal middle short x small bracket xi is equal middle bracket small bracket x0 plus h is equal I small bracket I is equal 0.1 point 1 n. One define the shift operation E by the relation EFI is equal EF plus 1 I G EF small bracket XI is equal F small bracket I H small E2 Fi is equal Fi plus 2 Fi E2F small bracket Xi is equal F EF small bracket Xi plus X is equal F small bracket I plus 2H E K Fi is equal Fi plus K, where K need to be positive or integer. E1 R2 Fi is equal Fi plus 1 R2. Why should we consider with the fractional power of E? We must use the formula to start with only every second value in table and later switch over the every below. Forward, backward, and central differences. In the difference table above, we form the first difference Fi plus 1 Fj, which are now given in the term of shift operation E is equal E plus 1 since Fi is equal E minus 1 Fi is equal EFI minus Fi is equal Fi plus 1 minus Fi. Similarly, 2 Fi is equal small bracket Fi plus 1 minus fi small bracket is equal small bracket e minus 1 fi plus 1 minus fi is equal fi plus 2f minus 2fi plus 2 plus 1 plus fi. In the manner Beno-Gill coefficients enter to the finite difference calculus, since plus fi is equal e minus 1 plus x minus 1 fi is equal small bracket e minus 1 fi. The central difference operation is defined by is equal e1 or 2 minus e 1.1 at fi is equal fi plus 1 or 2 f minus fi 1 or 2 and backward operator by is equal 1 minus e 1 fi is equal 1 minus e 1 fi is equal fi minus I minus 1. System of equation led to be square metric of order n and b vector the components. The system ax is equal b is b to be solved numerically in equation 1. The theory is complete and the sequence a number of solutions are known as function of the rank of a and of the nullity of certain characteristics determines if a is invertible, then Garmer rules allow a single solution x to be calculated. To consider numerically the situation is more complex. The use of Karimer method would involve an excess number of operation and problem propagation of routing error and extra memory space would increase the basic cost of the method. 3. Effective algorithm for numerical solution have therefore been developed. These take into amount of properties of a band structure blocks etc. and fall naturally into the two categories: direct method and iterative method. In the following is sequence invertible metric of order and addition the coefficient of a assumed to be real. This is not restive since the solution of linear system of an equation which coefficient in the complex will consist directly of solving linear system with two an equation with real coefficients. A small bracket a I b small bracket x plus I y is equal b plus I c. Numerical method for which is expressed as a b minus a small bracket x y is equal b c. It is important to carry out a transmutation systematically since the arithmetic unit of computer are very suited purposing complex number. Secant method, a root finding algorithm which assumes a function to be approximately linear in the region of interest. Each improvement is taken as the point where the approximating line crossing the axis. The secant method returns only the most recent estimate, so the root does not necessarily remain bracketed. The secant method is implemented in the form language as the undocumented option method. Sequence in find root big bracket e equal x x0 x1. When the algorithm doesn't coverage in this order, coverage is m where is a constraint and it is the golden ratio. F small bracket xn minus 1 minus f small bracket xn minus 2 xn minus 1 x plus n minus 2 f small bracket n is equal f small bracket xn minus 1 plus f small bracket xn minus 1 x plus 1 small minus xn is equal 0. F small bracket xn minus 1 plus f small bracket x n minus 1 minus f small bracket x n 2. So f(x n minus 1 small bracket x n minus 1 minus x n minus 2 f2 is equal f x n minus 1 f small bracket x n minus 1 minus f x n. Thank you. Here is my presentation over.